Every pixel in the game you played last night. Every frame of the AI video that just went viral. Every weather forecast. Every protein fold. Every LLM you've chatted with. They share one silicon ancestor, the GPU. So what is a GPU really? A CPU is a sprinter, a handful of very fast, very general cores, typically 8 to 64, each executing complex branching code, one instruction after another. A GPU is a marching army. Thousands of simpler cores, all in lockstep, each doing the same operation on a different piece of data. The formal name is SIMT, single instruction, multiple threads. For workloads where the same math repeats 1 trillion times, this is a 100-fold advantage. Zoom into a modern GPU and you'll find streaming multiprocessors, SMs, each a miniature computer with its own schedulers, register file and shared memory. Inside each SM, threads are grouped into warps of 32, the fundamental unit of execution. The memory hierarchy is brutal. Registers at the top, then tiny on-chip L1 and shared memory, then L2, and finally high-bandwidth VRAM, GDDR6X or HBM3, moving 1 terabyte of data per second. Getting this hierarchy right is the whole game in GPU performance. The GPU was born to render triangles. The classic pipeline still lives inside. Vertex shaders transform 3D points. Rasterization decides which pixels a triangle covers, and fragment shaders color each pixel, often running 100 million times per frame. Modern GPUs added dedicated hardware. RT cores for ray tracing, which trace photons through virtual glass and mirrors, and tensor cores. Matrix multiply engines originally built for deep learning, now upscaling your game with DLSS. Around 2007, researchers realized those thousands of cores were perfect for any math that embarrassingly parallelizes. CUDA opened the door. Today, GPUs don't just render worlds. They train them. A single H100 does nearly 4 petaflops of FP8 math. 8 of them fit in one server. Dozens of servers train the models behind ChatGPT, AlphaFold, and self-driving cars. The GPU stopped being a graphics card a decade ago. It became the substrate of modern computation. So next time your phone generates an image, or your game paints a photoreal world in 16 milliseconds, thank the unassuming chip doing 1 quadrillion tiny calculations, all at once.